In these problems, we're talking about prime and composite numbers. You may have heard of prime numbers before. Those are numbers where they're only divisible by 1 and themselves. They have no other factors. So the number 3, for example, is prime. Only 1 times 3 makes 3, no other combination. But the number 6, for example, is composite because, well, 1 times 6 works, but so does 2 times 3. So it's got some other factors. Just to remind you about prime numbers, the first few prime numbers, we've got 2, 3, 5, 7, 11, 13, 17, 19. Those are the prime numbers under 20. In this problem, it says state whether 360 is prime or composite. That's the first part. Well, how do you know? In this case, it's pretty easy. Any even number is divisible by 2. So I can tell already that 360 is composite. I know it's divisible by 2. Because it ends with a 0, I know it's divisible by 10, so it's got some other factors in there. So it is composite. And then it says, if it is composite, find the prime factorization. So the prime factorization is just a list of all of the prime numbers that you would multiply together to get 360. I think the easiest way to do this is start with 360 and then just start dividing it. In this case, it's an even number. Start dividing it by 2. So 360 divided by 2. So I divided it by 2. I'm going to list the factors over here, and that left me with 180. And that's divisible by 2, so let's do that. And that brings me to 90. And I divided it by 2 again. Let's see, that's still divisible by 2. That brings me down to 45 after I divide it by 2 one more time. And now let's see, 45 is not divisible by 2. I know that's divisible by 5, so let's do that. So that brings me down to 9 after I divided it by 5. All of these are prime numbers. That's why I'm choosing to divide by 2 and 5 and so forth. 9 is divisible by 3, so that leaves me with 3 when I divide by 3. And then to get down to 1, all I have to do is divide by 3 one more time. So those are the list of the prime factors. And if I punch all those in together, 2 times 2 times 2 times 5 times 3 times 3, yeah, I get 360. So I know I did that right. So that's my list of factors. Usually we condense this list a little bit. We put powers of the prime factors. So this is 2 times 2 times 2. That's 2 to the 3rd power. And let's do the 3's next. We'll put them in order. There's 2 3's, so that's times 3 to the 2nd power. And there's just 1 5, so times 5. So that would be a good representation of the prime factorization of 360. Let's look at another problem. So this one says, which of the following lists all the factors of 53 and correctly identifies 53 as prime or composite? Now this one's a little bit trickier. I can't immediately see that this is divisible by 2. I know it's not. It's an odd number. It's not divisible by 10. Doesn't have a 0 on the end. Maybe it's prime. I don't know off the top of my head. Let's just look at the answers here for some clues. One answer is that it's prime and its factors are 1 and 53. Well, that's consistent. If it is prime, those are the only factors. This one says it's prime, but it has these 4 factors. That doesn't even make sense. A prime number wouldn't have any other factors, so I can just cross that one off the list. C and D are other options, show that it's composite. And I think I can use what's in the answer here to test this. Is 53 divisible by 3 or 7 or 8 or 18? So let's go ahead and try that. I'm just going to punch 53 in on the calculator and try to divide it by 3. I get a decimal, so it's not evenly divisible by 3. Let's try 7. No, it's not divisible by 7. Well, and I know it's not going to be divisible by 8 or 18, but let's just show that. So there's divided by 8. Here's 53 divided by 18. So none of these make sense, and it looks to me like 53 is prime. So that is a little bit of work with prime and composite numbers.